Today we are going to build a modular drill bit holder. The reason being is that I've got my drill bits currently on a pegboard shelf. It means that if I want to add a new hole into this shelf, I need to take off all of the drill bits. I then take it over to the drill press and then I drill a hole with that drill bit so I get a really nice snug fit, and then I have to put it back. And slowly over time, as I'm acquiring more and more drill bits, it's just becoming a little bit of a pain in the ass to keep on doing this over and over again. So I wanted to come up with a system that would allow me to essentially keep the shelf in place and then just have holders that could be added to this over time. So let's jump into Fusion 360 and I'll show you how I designed this. Before we do that, I just want to say thank you to PCBWay for sponsoring this video. From multi-layer PCB etchings to metal 3D printing, PCBWay can help you prototype your next idea and bring it to reality. They offer fast worldwide shipping and low minimum quantity orders across the majority of their services. So be sure to head over to PCBWay.com today and see how they can help your next project. What we do is we'll start off with the easiest of the two parts, and that is the base plate, because it's just essentially a bit of wood with a load of holes in it. So let's sketch that up in Fusion. We're going to create a new sketch and we can select any plane, but we'll select this bottom plane. Now we want to draw a center point rectangle, and this is going to be the overall size of the base plate, and I'm going to go with 300 millimeters by 200 millimeters. Now we don't want the holes to be right up against the edge because obviously we want to leave some material around the edge. So what I'm going to do is I'm going to create a construction line and we will bring up an offset. We'll press O on the keyboard. We'll select the rectangle and let's bring it in by -10. So -10 millimeters. And now I've got a guideline of where I want all of these holes to be situated. So now we can go ahead and we can just draw the holes. We don't need to draw them all, we'll just draw one and then we'll use the rectangular pattern. So we'll draw a center diameter circle. We'll draw it anywhere at the moment. We turn off the construction and we want this to be 16 millimeters. And now we can go ahead and we can constrain it to where we want it. So let's bring up the tangent constraint and we want this to be tangent against here and also here. So now it's locked in place against those two construction lines. Now we can go ahead and we can create the rectangular pattern. If you've never used these type of tools before, just looking at the UI panel for these various different tools will usually just help to tell you what you need to do. You need to first of all select an object. So this is the object, and then you need to select the directions. So we want to bring it out this way. We also want to bring it down as well. Now you've got two options. You've got extent and spacing. We want to do it to extent because the extent is right here. We want it right up against these edges. And then the same, we want the extent to be right up against those edges. But we've only got 3 of each at the moment, so we need to increase the quantity. What I do is I just keep on clicking it until it feels like it's getting a bit too cramped. So you can see that there, for instance, there is hardly any material between these holes, which isn't going to be good. But that looks okay. So we'll say 10, and then on the other direction, we will just keep clicking until it feels a little bit too crowded and there is too little material. So yeah, that's going to be too little. So there we go. We've got 16 by 10. So there's 160 holes that we've got. So we're going to be able to fit a lot of drill bits. Obviously, some of the heads of the drill bits, they might be larger than 16 millimeters. So you probably won't get 160 in here. If you're using small size drill bits though, yeah, you would be able to fit quite a lot in here. So we'll click on OK and we'll just let it draw that geometry. If you ever want to change this grid, all you need to do is find the original bit of geometry and you can see that these are all of the kind of like the constraints, and this one here is the grid rectangular pattern. So we can come in and we can go ahead and change it if you need to. But that looks good to me. We will click on finish sketch and now all we need to do is extrude it. So we'll bring up the extrude command. You can press E on your keyboard. I've got the Space Mouse, which was recently gifted to me by the company, which is very kind of them. And I've got a radial menu that I can set up, and I can bring up all of the my most used commands up in that radial menu. So if you see that, that is with the space mouse. That is not within Fusion. We will bring up the height of the material to whatever we're using. I've got 18mm plywood, so I'm going to make it 18mm thick. We'll press OK. And there we go. That is the base plate done. Now, the last thing to do is bring up the fillet command. So you can press F on your keyboard. I've got it linked in this radial menu here. And we will just select these 4 corners. And we'll just put anything really, it doesn't really matter. I think 10mm, yep, that looks fine. So there we go, that is the base plate done. Now what I want to do is I'm going to bring it over into the manufacturing section and we'll just set it up. I'm just going to show you what I use to machine this on my CNC. So here we are in the manufacturing tab. We've got 2 operations to do. We need to cut these 160 pockets and then we'll do an outer contour to cut it out of the bigger sheet of plywood. So first of all, let's go ahead and select all of these 160 holes here. So you don't have to do it individually. You can set up some selection filters to make it a little bit easier for yourself, and you can also create a selection set. First of all, we will set up the workpiece. You can do this however you want, but what I always do is I will select the Z-axis, which is going to be this top one, and then I will select my X-axis, which will be this, and then what I do is I always put my stock point in the top left corner. So that is how I have mine set up. Then also you've got the stock, so you can choose your offsets, how much you want to have on your sides, your top and your bottom. We won't have anything on the top and the bottom because we've just got an 18mm sheet of plywood, but the 1mm on the outsides will be fine. So we'll click on OK, and what we want to do now is just create the selection set. So we'll come around to the bottom of the piece, and you can also just keep it nice and flat here. So what we want to do next is go to the filters, and then we will select edge priority, and then we can click and drag, and you can see that that has only selected these bottom edges here, which is exactly what we want. And we don't want to select the top ones, because when you're doing a pocket you just want to select the bottom geometry. And then we can right click on any of these and we can create a selection set, and you can see that that has got the 160 holes. And then we can always just come back, if we unselect it, we can always come back, click it, and then we can select them all. So we'll go to the 2D pocket. Obviously this will just be dependent on your machine and the tools that you're using. I'm just going to be selecting my straight bit, 2 flute, 6mm end mill, and then for the geometry we will then just click on the select. So we're going to tell it to select all of these 160, and this is what we want to cut for the geometry. Now this really does slow things down. Really slow things down. This takes a good 3-4 minutes for my computer to select all this geometry. There we go, we've got them all selected. So that did take quite a long time. I've got a pretty fast PC, so I can't imagine how long it's going to take on someone with a slower PC, but you can see they're all selected on the bottom. And now we will go into the passes sections. I mean, if you've got a powerful CNC, you can just plunge straight down into 18mm plywood and just do a spiral cut. Me, on the other hand, I can't really do that. First of all, I don't want to leave any stock. I just want to cut this in the one setup that we've got. The multiple depths, we will do maximum roughing step down will be, so let's just do it like 10mm. Let's just do it in 2 passes basically. And we don't want to leave any stock. We don't want to do any smoothing. And then we will do the linking tab, and we want to lead in. We don't want to lead in. We just want to do a ramp, and helical ramp. We can be quite aggressive with this, to be honest with you, because most machines, they can probably handle a plunge straight down. So seeing as most machines will probably be able to just plunge straight down, I don't like to plunge straight down because it is just a flat bottom end mill. But we can make this degree a little bit aggressive. You could probably put it like 10-20 degree, and it's basically how much it's going to spiral down. So obviously the bigger the degree, the more aggressive it's going to spiral down. But if you put it to like 20 degrees, I'll just show you here. Let's just generate all of this. This is probably going to take quite a long time. So you can see this is the ramp for the spiral. You can see that it's quite aggressive, but it should be hopefully a little bit more easier on the end mill as opposed to just plunging straight down. But there we go. So we've got the operation. You can see that it's doing spiraling down, and then it's cutting the outer geometry, spiraling down, and then doing one last at the bottom there. So we're just doing it in 2 parts. This is a 6mm end mill, so yeah, it should be able to handle it. It shouldn't have too many issues with plywood. If this was hardwood or something like that, yeah, I'd probably go a little bit more conservative. But what I find is that I can always just reduce the feed rate, and I can up the spindle speed if it's starting to get bogged down. I can do that on my actual CNC controller box. So I just usually set things around about, middle ground in terms of aggressive and conservative in terms of speeds and feed rate. And then I just adjust it depending on how it sounds when it's actually machining. Next, we'll do the outer contour. And this is not going to be exactly an outer contour. It's going to be a full slot because the plywood is actually quite a bit bigger than this 300 by 200. We need to be a little bit conservative in terms of the feed rate and the passes. I mean, if this was just a kind of a contour cut, I could just go full depth and we'll just take off 1 millimeter around the edges. But it isn't like that. It is as I said, a full slotting cut. So we'll probably do this in, let's just say 6 millimeter, and we'll just go into the linking. We don't want to lead in, but we will want to ramp it in, and we'll just click on OK, and then there we go. So you can see it's just going to ramp in, get to 6mm, do the cut, and then it will just keep on stepping down as it goes. One thing that you can do that I forgot to mention in the design section is that you need to think about how you're going to be fixing this to whatever you're fixing it to. I've got either pegboards or I've got French cleats. Really, I'm not really leaving myself much material here to think about fixing. What I would probably do is I would maybe just select, if we just go to remove the select priority, if we just go to the, we just clear all of these, that's fine. What I would probably do is I'd maybe just delete like these 2 here, for instance. I'll delete those 2 holes, so then I've just got a little bit of space so that then I can fit a French cleat onto the back of this, basically. That's kind of what I'm thinking. So you need to think about that. However you're going to be fixing it, maybe you just leave a few holes blank so you can fit in what you need to fix it onto the wall. So that is the base plate complete. Next we will go ahead and design the 3D printed modular bit holders. And my original design was actually to make the holders, as you can see here, the barrel that goes through it is going to be angled. After using it for a few months, I've realized that actually I didn't really need to complicate this design, and I think that really this hole that just goes through it, it could just be a straight hole like that, and it will make the design of this much more simple. Because if you look at the way that I've got this design laid out, you can see that as the hole gets bigger, it does actually start to come through the outer edges here, and you actually have to start the hole higher up to make sure that you don't lose too much material here. You can see on these ones, for instance. So yeah, I think that the way I'm going to redesign this for this tutorial is to just go over a straight hole through it. So let's get started. First of all, we want to create a new component because we are going to want to be able to copy and paste these components, and then we want to be able to edit each one independently. So what I did for this layout is I just designed the first one, and then I just copied them all, and then I went into each one and I just changed the original geometry, the original sketch, to whatever size drill bit that I wanted. So that is how we're going to do it. So we'll start with this one, and we'll say that this is just going to be for 1 millimeter. So we're going to start with a center point circle, and this is going to be the outside geometry. So we know that the holes that we just cut for the plywood base are 16 millimeters. I'm going to give myself a little bit of clearance, so we'll probably go with something like 15.9 millimeters. Now next for the hole, I think it's a good idea to set up a parameter for the clearance. So if we go to change parameters, you can go to modify, and then you will see change parameters here. And we want to create a user parameter. So we can select the plus icon and enter a name. So we'll just say that this is going to be the clearance, and this is going to be, we'll give it 0.2 millimeters. And then we can always come in and adjust this if the drill bits are not really sliding in and out perfectly enough. I think 0.2 should be enough. So now what we can do is we can come back to the sketch, and we'll draw a center point circle here, and we'll just say 1 millimeter and then plus the clearance. So the way that we have it laid out like this. Now, if we find that the drill bits are not really going in and out when we're prototyping this, instead of having to come back into each individual drawing, like here, for instance, I would have to click on each one, come into the original sketch, change the sketch geometry. Now, all we need to do is we can just come into the user parameters. We can change that clearance number, and then they will all be updated because they're all referencing that user parameter. So we've finished the sketch, and now let's just extrude. So I'm just going to bring up my radial menu, and the plywood is 18 mil, so let's just make it 18 mil. Well, actually, let's make it 16 mil, and then we will extrude the bottom. Now, it's up to you if you want the hole to go all the way through. What I thought was that my drill bits they might just slip out through the back. So what I did is I extruded the bottom as a solid base, basically. So if we just bring back this sketch and we bring up the extrude command, we'll select both of these and we'll just extrude it by -2 millimeters. So that gives us the 18 mil height now, and it's obviously capped off at the end here. Now, before I add any other geometry to this, I do want to just add a very slight chamfer on the top. And then I do want to add a little bit more of a bigger chamfer on the bottom, just so it's a little bit easier to push these into the holes of the plywood. So let's create a sketch on the top here. And now we're going to add the flanges. So what we can do is we can just add a center circle again. And I'm just doing this by eye, really. So we'll just make this 3 millimeters. And actually, let's not constrain it at the moment. Let's just position it anywhere at the moment. And what we'll do is we'll just do a circular pattern. We'll select the object that we want. Then we'll select it around this point here. We just zoom out, and then we can increase the quantity. Yeah, I would say something like that looks okay. And now we can bring up the extrude command. We'll just come out of the sketch, bring up the extrude command, and then what we want to do is we want to just extrude all of these, and now we will extrude these down, and that's fine. So if we just come all the way down to this part here, click on OK, and then there we go. So what we can do next is we can just add, if you really wanted to, you could just round off these corners. We could just bring up the fillet command, and then we could painstakingly go through and select all of these, and then just add like 0.5 fillet just to soften it off. And this is obviously just going to help to make pushing it into the plywood easier. But for now, I mean, as a basic design, I think that looks good. What we do now is we will duplicate these for all of the different sizes, and we will just come in and we will edit the original sketch just to match the size of the drill bit. So to do that, we will right click on the component, we'll select copy, and then we'll right click on the main component, and we want to paste new, and then we'll just move it over here. And what that does is it creates a new version, and we can call this 2 millimeters, and we'll now activate that component, and we can come into the sketch and we can make this, so we can just change this to 2 millimeters. We'll finish the sketch. You can see now we've got the bigger hole, and you just keep on repeating that until you've got as many as you need. I've gone up to 13 millimeters. Now what I did also experiment with, and it didn't come out very good, was adding text to this face here, so you could actually see what size drill bit it was. But to be honest with you, the detail I was getting printing this on FDM printer was not very good. I did end up printing them on a resin printer, and that was much better. But again, still, the text didn't really come out that good. I think it's probably because I don't have a very good washing setup for my resin prints. But that's something that you might want to add as well. You could also, go ahead and engrave it onto the actual plywood base if you know exactly what you're going to be putting. But the whole idea of this being modular is that you can swap and change things around. So I didn't bother with any sort of markings really on the setup at all. So that shows you how I store my drill bit collection. As and when I acquire new drill bits, all I need to do is 3D print an individual holder for the size of the drill bit, and then I can just push it into this base. Thank you for watching. Remember to like and subscribe, and I'll catch you later.